did with these, I think the notes are a little bit more difficult than the assignment because the notes take 2 examples and have us find every single thing possible. And what I did with the practice problems is I chose problems, and then I had us just find a few things for each of them, and I made sure that like the crazy answers that would have been real funky, we just didn't find for that problem. So if it had one answer that was like, ooh, that's really complicated for that particular problem, I went like, let's not find it for that one. So I like chose things specifically that would not be terrible. So like if the range was real weird, I was like, let's not find the range, let's only find the domain. Or let's only plug in numbers. Let's only find the intercepts or something. So that it wouldn't be as crazy. So the notes feel pretty intimidating, but the assignment themselves, the problems there, instead of asking you to fully analyze the function the way that we have been doing, these ones ask you to find specific things and then kind of move on to the next problem, okay? All right, so for number 2, first thing, plug in -6, it says. So if we look at the 2 different pieces that we can plug numbers into, if we're plugging in a -6, which one do we get to plug it into? Yeah, the top one. -6 is less than -3, so we have to plug it into this one. So I'm going to have -6 plus 4 squared. And so what is that going to give me? -2 squared. 4. Good. We're not killing any baby otters. We're keeping them alive today. Keeping them alive. Alive and well. Okay? What about plugging in -3 exactly? In the bottom one, because that's where the equal to is. Okay, so we've got the negative version of -3 minus 3. Negative version of -3 minus 3. So it's +3 minus 3, which is 0. Okay, so it's +3 minus 3 is 0. Okay. And that fits, right? We can see that on the graph. At x equals -3, we have 0. At x equals -6, we had 4. Okay. If we plug in 0, which one do we plug it into? The bottom one, 0 is bigger. Okay. So the negative version of 0 minus 3, which is just 0 minus 3, which is -3. Okay, that fits. That's on the graph. Okay. Plugging in 10, which one do we plug it into? The bottom one, 10 is greater than a negative number. So we're going to do the negative version of 10 minus 3. And what do we get? -13. And it's not on the graph, but over here, if we went all the way over to 10 and went down, like it would eventually be like, yeah, that kind of fits. Would it be -13? That makes sense. Those are all logical answers. Okay, the domain of the graph. I can see it's going left forever. I can see that it's going right forever. The only thing I'm concerned about is this little gap right here. I think that it might not have this number right here, this x value of -3, because it's missing right there. Is the x value of -3 actually missing? No. So what do I see overall with the domain? Yeah, it's all there. It gets weird in the middle.
That's going to be the domain for everything we learn.
It was in the first unit when we had the U-shaped graphs and the V-shaped graphs. That was true for those. But now that we have these graphs, sometimes it could not be true.
What would it be?
Remember, there was a graph that we did yesterday. Yeah, the not continuous one, it had a graph. I don't remember what the left side looked like, something like this, and then the right side was like this. If there's a gap, that would be a domain that had something missing. Yeah, so the one that had a gap in it, That one did not have a domain from negative infinity to positive infinity because there was, yesterday it was the x values between -3 and -2. They were just missing. Yeah. So every so often we'll have some of those. Negative infinity to infinity is a very common answer, but it's not every single time. It's just often. Yeah. Yeah, so I looked from left to right. That's where I always look first. And I saw, okay, it's going forever to the left, forever to the right. So that was where I was kind of thinking like, okay, we're starting off with this. And then I look for anything that's weird. So this in the middle was weird. And I said, okay, is there a value that's missing in the weird part? And I could see that right here, the x value of -3 was missing. And so then I looked and said, if it's missing there, is there somewhere else where it's not missing that x value? Well, right here, it's not missing. It's filled in. So if it's filled in right there, that means that even though it was missing in one part, it was there in another part, which means by default, it's like there, that it actually showed up on the graph. So it means even though something weird happened, it's technically not missing, which means all the values were used. So if they said like, for every single x value, tell me what the y value is, I could say for an x value of -3, there really is a y value that exists. Yeah. So all the other x values were fine. Those were all definitely given. The only one that caused us to pause for a moment was -3. That was the one that made us think. So we're going to do the same thing for the range. We're going to look down and we're going to look up. And when we look down, all these down numbers, those all are comfortable for us. We feel confident. Those are all there. All the up numbers, those are confident. We feel good about those being there. The only thing that's weird is these numbers right here in the middle. It gets really weird right around 0 to +1. That's where things get weird, right? So 0, there's just extra numbers at 0, so that's okay. And then if I look at +1, a y value of +1 is missing right here. But if I look over here, there is a y value of +1. Everyone see that? So it looked like it could be missing, but it actually wasn't. Okay, so what should I say about the range? It goes, wait, which one do I write first? Yeah, it goes down forever, up forever. I thought one was missing, but it ended up not being missing. It made me pause for a second, but it ended up being fine. Okay. All right. At this point, let's go ahead and do increasing and decreasing. So I'm going to write my stick figure. And when we do increasing and decreasing, do we use x values or y values? X. We always just all x values. Okay. So my stick figure is, this is a very steep hill, so he's really just rolling down this hill. And he comes right down to the bottom of the hill, and then he rolls up a little bit. And then he goes into this hole and magically disappears. So this stick figure is gone. Like he gets vaporized. Yeah, but it's a white hole. Fell into a white hole, burned into an abyss. I don't know. Something weird happened. This is a new stick figure. We can tell that he's new because he has this hair. Okay? And so we're starting all over again. This is a new guy, new man. Okay, and this stick figure is going down. Now, this is not like sliding down. This is like a skateboard ramp, but he's also going down. It's very fast, though, because it's not like, it's just straight. That would be very scary. This is like a wooden ramp, but not curved, just straight. And forever. And it never stops, just forever. Yeah. Okay, so what's the x value right here? Yeah. It's a left arrow. Negative infinity. X value right here. Okay. And then the x value of the abyss. -3. Okay. The x value of the new stick figure. -2. Wait. 3. -3. So the new stick figure starts at -3 to infinity. Right. It's a right arrow. Yeah, so you were correct in thinking negative infinity if you were thinking in terms of y, but we're thinking about the x value, so we're thinking infinity. Okay, so increasing is just a very little answer. The word increasing is in between these numbers right here.
So
-4, -3. Okay, now these both get to be parentheses because at this exact moment in time, he's not going downhill, he's not going uphill. This has to be a parenthesis because the moment he's burning up into the abyss, that point is not really on the graph, so it can't be included. Yeah.
Then the decreasing was -3 with infinity. So, but we would still put a parenthesis.
Yeah, we have to put this one first, so you're right about the -3 to infinity.
So negative infinity to -3 and then -3 to positive.
Wait. Negative infinity to
-4.
-4. Okay. Okay, and then we have to decide if these should get parentheses or brackets.
Well, -4 should go to parentheses.
Yeah, because at the very bottom, it's...
-3 because it's not really moving at that point, is it?
So at this one, now here's what I'll say. If you want to, for increasing and decreasing, always put parentheses, you'll get the answer right. Like all the way through calculus, you can just put parentheses all the time and they won't give you every single answer right. They'll give you full points. But technically, since on this one, if he stands right there, is he moving downhill? Yeah, he's moving downhill. This is not one of those situations where he's in between. Do you see how right here he's in between? But do you see right here how he's on the downhill part? So this one, you could include it.
Because like at -4, that would be a minimum. But at -3,
At -3, he's actually there. He's actually on the downhill part. Why would the increasing what? Because at the 3 right here, it's a hole. It's not actually a real point on the graph. The -4 and the decrease is not because you're right in between. See how it's like right there? It's not going down, it's not going up. It's like in the in-between of the going up and going down. But this one, see how it's actually part of the downhill slant? See the difference between all those? Now, I do know that that's really confusing because it's like 3 completely different situations. So if you want to say, okay, for increasing and decreasing intervals, I just never use a bracket. I just always use a parenthesis. That's fine. Yeah.
Will you take points off when we don't go back?
I will not. This -3 right here had a bracket because it's included in this downhill slope. It's actually part of it. This -4 right here did not because it's technically in between a downhill and an uphill. Do you see how it's in between? This one did not have a bracket because it's a hole in the graph. It's not even there. See, so we're really talking about 3 different situations, and all of them have 3 different explanations. They're all at this level of math, they feel very complicated. If you just want to say, for these answers, I never do a bracket, I will mark you right every single time. I'm fine with you doing parentheses every single time. Because, so I teach calculus also, not here, but I've taught calculus for several years. And even at the calculus level, if students put parentheses, they're fine with it. Yeah. Yep, you're good. All right. Maximum. Are there any mountaintops? Mountaintops in the picture? Anyone? Okay.
There's a valley.
None for mountaintops. There is a valley. What is the point for the valley? -4, 0. Okay. Are there any X-intercepts on the graph? Does it cross the X-axis anywhere? Yes. Where does it cross the X-axis? -4. Where else? And -3. Okay. Are there any Y-intercepts? -3. Okay. All right. Is the graph continuous? Can you trace it with your finger without picking up your finger? No, you gotta, pick up your finger.
So I thought it meant when it's continuous, it goes on.
Nope.
So it just means.
Yeah, the word for that is called unbound. And so, yeah, so bound, and we haven't even talked about, we haven't even talked about boundedness, but in math, that's what they call it. So bound means it has like ending, it stops. Unbound means it goes on forever.
See, I never knew I'd have to
Yeah.
study so much vocabulary in math class.
I know,
used to
right?
take flashcards.
Yeah. All right, end behavior. Let's talk about our arrows. So as we look at the left arrow, as we look at the left arrow, what is the left arrow doing?
As X goes
The left arrow? It goes up. The left arrow goes up. As we look at the right arrow,
wait, as we hold on.
left arrow,
That's the left arrow.
left arrow goes, left arrow goes
Oh, I see, because I keep
up.
looking at the lines.
Left arrow goes up. Right arrow goes down.
Okay, so the right arrow is going down, the Y is still going down, right?
Left arrow goes up. Right arrow goes down.
And we're both talking about Y in the situation.
Yep. X is left. Left arrow goes up. So left, X is left, Y is up.
But then on the
Left,
other one,
up.
X is right.
X is right, Y is down. So the X is left and right. So left, right. Y is up and down.
So I'm looking at, when I'm doing this, I'm looking at both.
Yep.
So I'm looking at, so not just Y's. I'm looking at both.
So this first line describes this arrow,
Okay.
and this one describes that arrow.
X is going over to the left, Y is going up.
Yep. The left arrow goes up, the right arrow goes down.
X is going forever.
To the right. Mm-hmm. Mm-hmm.
Y is oh.
Mm-hmm.
See, I'm not going to remember how to do it, though. It just takes some time. That was
All right.